Okay, time to roll up our sleeves and get into some of the technical aspects. So what I'm going to do first is do a short summary of the basins that we've been looking at. As Rob alluded to, there's a massive amount of data, and one of the biggest challenges was, of course, to comb through that data to see what's been done, and also to vet the quality of the work that's been done as well. And that's where our expertise comes into play. So I'm going to do a short summary, and then we're on the agenda after that. We're going to have I think a short break after that, and then we're going to talk. The delegation from India is going to talk about some of the business aspects, which are also very important to the play as well, of course. And then we're going to move into a more detailed technical summary of the two basins. And one of my colleagues, who's not here, but who will be online zooming in, Mike Estelle, will be addressing the Mahanadi Basin and the Bengal Basins. I'm going to talk about the Andaman Basin. So let's get started. Let's start with a quick summary. So as you can see, so let me try it this way. Obviously, this is a map of the sedimentary basins of India, both onshore and offshore. And our focus, of course, is the Andaman Basin. And the Andaman Basin is actually divided into two. One is the East Andaman Basin, which I'm going to talk about a little bit more. And the West Andaman Basin is more outboard into the Bay of Bengal, into the deeper water. And it's on the west side of the Andaman Islands. So there's a distinction between the two. And the geology is significantly different. And that's why it's set up that way. The other basins, of course, are the Mahanadi. Now, the Mahanadi has both an onshore and an offshore component. We're focusing on the offshore component. And similarly, the Bengal Basin, which is adjacent to the Mahanadi, and really kind of a compound set of basins, really. The geology is very similar until you get down into the earlier rocks. So although they've been sort of separated, we're trying to combine them and look at them both in combination. So the Bengal offshore as well. So let's talk about the East Andaman Basin first. Well, here's the physiography. As you can see, the mouse works. There we go. Andaman Islands, Nicobar Islands. These are the international boundaries with Myanmar. Actually, there should be another boundary here, like this one, between Thailand and then, of course, Indonesia down to the southeast. If we look at sort of the depths of water, the bathymetry, you can see that there's a lot of variation in here. Obviously, there's a lot of tectonics and a lot of geology. I'm going to talk about that in a minute. And sort of the East Andaman, of course, here's the Andaman Island here. So we're really talking about the East Andaman Basin. You see a lot of variability up to, I think that's up to, hard to read, I know, almost 4,000 meters of depth of water. And just to put it in perspective again, the West Andaman Basin, of course, is outboard of that off to the west. So we'll talk about some geology, the tectonic setting. The West Andaman Basin is relatively simple. As I said, it extends out into the Bay of Bengal. But the East Andaman Basin is very complex. And the reason for that is because of tectonics. It's at the edge, it's at the plate boundaries. It's actually in a subduction zone between the Asian and the Indian plates. So it's created a lot of complex geology, as you can see. There's an accretionary prism, there's a volcanic arc, there's back arc basins. And just to look at the real data, this is a seismic line. And if I go back up, basically this is the hypothetical. This is about where that seismic line, A to B. And you can see the geology is quite complex. So that's both good and bad. I mean, it's bad in the sense that it's a lot to figure out and a lot to try to untangle. It's good because there's a lot of opportunity, particularly with structural geology. So the stratigraphy is quite varied. The oldest rocks are basically Cretaceous in age. Down here, kind of in the basement, there are some sediments down in the Cretaceous, which do have some value. There's probably some source rocks, but most of the focus is in the tertiary, from the Paleocene up to the Miocene and the Pliocene. And as you can see, just from the lithocolumns here, there's a lot of variability. There's a lot of clastics, some shallow water, some deep water, but there's also carbonates. There's potential for reef buildup in here. So there's a carbonate component as well. And in fact, the one discovery that's been made in the basin is in a carbonate-hosted reservoir, which we'll see in a minute. Okay, work done to date. As Rob alluded to, there's a lot of seismic, both 2D and 3D. And this is the map that kind of summarizes it all. It summarizes some of the reports. You can see there's a lot of coverage, particularly where the sediment package is thickest, where the most potential is. And The challenge here, of course, was to try to make sense out of all this, and we're still in the process of doing that, quite honestly. We're still collecting data from this basin, and it's all going to go into the U of H's server so we can work on it. There have been some wells. There's been 21 wells drilled. As you can see, most of them kind of TD'd, in the Cretaceous, some in the Miocene, some in the Eocene. And they're alluded to one, which is a discovery, which is the AN1-1, but there are also gas shows in some of the other wells as well. And in fact, this one actually was picked as gas bearing, but subsequently abandoned. Of course, there's no infrastructure out here, so any considerable, any shows so far remain as shows or tests until the infrastructure is in place for production. So there is no production out here. These are locations of the wells. As you can see, they're kind of grouped into this area east of the Andaman Islands. If we focus in a little bit, so we can see these wells, that's the AN1-1 discovery well. So it was followed up with 3 other, or maybe 4 other, I forget, other wells, which were not as successful. Oh, sorry. Get to that in a minute. But, when you look at the density of wells, there's still lots of opportunity to follow up on this play, as you can see. All right, quickly, I'm going to talk a little bit about source rocks. You can't have a petroleum play unless you have mature source rocks. So there has been some geochemistry done in here. So there is TOC values. There's some maturity values. And really, for the East Andaman Basin, we're looking at depths, I think, early maturity around 2,200 meters of depth and full maturity at about 3,800 meters of depth. And in terms of what rocks fall into the mature window, basically, as you can see, the Paleocene, the Eocene, the Oligocene, and a bit of the Miocene, perhaps, all fall potentially within a maturity window. There was a big petroleum systems model that a lot of this data was derived from, and they went in and sort of looked and modeled the TOC content. And these are the various zones. I know you can't probably read the stratigraphic layers, but basically what they've said is that there is a significant amount of TOC potential here in the source rocks that they have identified. You can't see the scale, but the ranges are up to about 2–2.5%, which is more than adequate for the generation of hydrocarbons and gas. So there are, the organic content is there. They also modeled the pseudo reflectivity of it, so the Burnham and EZRO percentage. And again, you can see that particularly in the Paleocene, there's a large amount of the source rock that actually falls within the oil window, which is encouraging. And as you get up into the Eocene, probably less so. So the assumption is that we do have TOC and we do have mature source rocks in the area. There's also biogenic potential. There are existing gas discoveries and developments, particularly over in the Mahanadi, that are biogenic in nature. Biogenic, just by its nature, of course, is usually in shallower reservoirs. You have to have specific water temperatures and chemistry to generate biogenic sources. But that obviously can occur here. We know we've seen reservoirs higher up, right up into the Paleocene or the Pliocene. That has potential for biogenic. I would classify it right now as a secondary play. I think the focus, of course, is going to be on the petrogenic plays, the deeper rocks where I showed you the source. But the biogenic is there as a potential secondary play, and it should not be ignored. Okay, reservoirs. I talked a little bit about this. This is another stratigraphic chart showing the formation names and where some of the reservoirs occur. And as I mentioned, you can see, right down into the Cretaceous, up into the, particularly in the Miocene and the Pliocene, there are a lot of sandstone reservoirs, and these have been identified potential. These are reservoir facies map, ISOPAC and reservoir facies map. So again, I'm looking at the mid-Miocene here. It's an ISOPAC map, and you can see it's up to, well, almost, I would say about 700 meters of thickness. And within it, we see a lot of potential for both plastic and carbonate reservoirs. And in fact, this is the carbonate reservoir. This is the discovery well, the AN1-1. And you can see it falls on a carbonate trend, which is, again, is encouraging. If we want to look at that in a little more detail, this is a cross-section between those 3 or 4 wells in the vicinity of it. AN1-1 is here. You can see that it has some continuity. Obviously, it's a limestone carbonate buildup. And This well actually flowed at 180,000 meters cubed per day, which equates to about 6.4 million cubic feet per day. So a very significant production rate. So what other traps are there? Well, as I mentioned, this is a structurally complex area, so the vast majority of the potential lies with structural traps. This is a time structure map of the deepest measurable reflector, and you can see there's a lot of variability, and they tried to impose some of the faulting on here. So we know there's a lot of faulting. You saw it on that seismic line that I showed you. There's also potential for stratigraphic traps, not just carbonate buildups. There are some unconformities in here. There's potential for pinch-out traps and stratigraphic traps as well. Here's an example of one of the structural traps. Pretty clear that, on this 2D line, at least, it looks as though there's significant closure. I think this is the early Miocene. It's a carbonate structural trap. This is the kind of thing, obviously, in a complex area like this. There's these types of structures all over the place. And in fact, in the previous work, they've gone through and they've cataloged a lot of the prospects already, and they've created these summary sheets for them. So these are in some of the reports, which we're going to talk about in a little more detail later on this morning. And again, so this trap is actually one of the potential stratigraphic pinch-out traps in the mid-Miocene. So it's a truncation type play. So there's both structural and stratigraphic components in the east end. Well, what's the resource potential? So the model went in and calculated what the resource potential is. And you can say it's pretty significant, particularly in the Oligocene. Overall, there's about 359.1 million metric tons equivalent of oil. Or hydrocarbons. And the Oligocene obviously shows the best promise with 235.4 million metric tons of oil, which equates to about 1.68 billion barrels of oil. Overall, 2.5 billion barrels of oil potential. I did a little, this is kind of hypothetical in many ways. And please don't go back and quote me on a lot of these numbers because I had to make some assumptions. But I wanted to look at some of the plays. So they defined, I showed you some of the different play types. And I wanted to see what the size of some of these plays were. So I started doing some volumetrics. So I took the area, as you can see here for these plays. These are 20 of the top plays in the area. I assumed I didn't have a lot of porosity or saturation values, so I had to make some assumptions, which I did. I was able to, estimate the depth and just using a hydrostatic gradient, calculate the reservoir pressures. And subsequently, I was able to do volumetrics for the top 20 plays. So I calculated both the potential for original oil in place and the potential for original gas in place. And so these would be individual, plays, individual pools, if you will, if they were discovered as such. And you can see the range anywhere from 36.6 million barrels of oil up to some pretty significant numbers, 467.1 million barrels of oil in place. That's world class. I mean, there's no doubt about it. Similarly, on the gas side, and I should mention, obviously the shows and everything are kind of indicating that this may be more of a gas-bearing basin. So this is maybe more valid to look at the gas potential. But the potential is quite significant, up to 1.4 trillion cubic feet of gas in one particular structure. Again, that's a world-class play. There's no doubt about it. I didn't touch the recoveries. I didn't want to worry about that. That's something that we're going to work on later, obviously. So this is a real good summary of what you might be able to find in here. And obviously, I think it's pretty significant. Let's have a quick look at the West Andaman. Again, it's a little bit different maturity. It's a little bit cooler, not as much tectonics. I think I put in, yeah, I did. So early maturity is a little deeper, 2,200 meters. Full maturity, about 4,000 meters of depth. Again, you can see the Paleocene, the Eocene, and the Oligocene are the main areas that fall into maturity. We don't have a lot of data on the West Andaman Basin. It's obviously a very vast area, extends out into the Bay of Bengal. But there was some study work that was done. So there was some seismic, and a lot of the work, there are no wells, quite honestly, but there's been some seismic done. So a lot of the work that was done was based on modeling off this seismic. And you can see the grid of seismic. There it is, and there it is in detail. However, there are some wells that are nearby. There's 3 deep sea drilling program wells drilled in the Bay of Bengal. 217 is the closest. It gives us some indication what the reservoir potential might be. There was also a well AN2-1, which is actually drilled on the west side of Andaman Island, but it's on the Asian plate, so it's theoretically not in the West Andaman Basin. It's in the East Andaman Basin, but it does give us some indication of what's going on. And this is that well right here. So again, we see potential for reservoir, we see potential for seals, probably potential for source rock as well. So based on the structural analysis, there have been some prospect areas defined, some potential prospect areas or lead areas, both for the Cretaceous and the Tertiary, which are defined here. And they did some calculations. Now remember, this is a relatively small area. And based on a aerial yield method, they did a calculation of what the resource potential is. They calculated what the potential number of prospects are. And they came up with a value of 12.2 million metric tons of oil, which is equivalent to about 90 million barrels. But remember, that's a fairly small area. So that the basin itself is quite vast. So I say there's still a lot of potential in there. Okay, Mahanadi. Again, a lot of data collected. Seismic, 3D, 2D, sniffer surveys, gravity surveys. A lot of it, some of it onshore, some of it extending into the offshore. Most of the wells were drilled on the onshore side, and they have most of the data, but they're also offshore wells. There is oil and gas development in the Bengal Basin as well. That's currently ongoing. But you can see there's a massive grid of seismic, both 2D and 3D. The geology, again, is in some ways simpler, but until you get down into what they call the Gondwana section, it gets a little more complex, where there's some grabens and horse blocks that are associated with some of the pull-apart basin at the time. You can see, obviously, as we move outboard, we move from shallow water sandstones into deeper water potential sandstone, but there is reservoir potential out there. There's also potential for source rocks and reservoir. This is a good summary. I know it's not clear, but you can see the intercalation of both sandstone and eventually organic shales as well. Those are based on some of the onshore wells, but it projects into the offshore. Again, they've modeled the TOC content. There's significant TOC content up to about 2%. So again, significant, high enough to generate hydrocarbons. Again, this is Mahanadi again, so the model of the maturation, and we see an oil window. We see, obviously, as we move deeper into the basin, we get into probably an over-mature gas window, but there may be some very significant gas accumulations as a result. And a lot of this modeling, you can see, has been done in detail as well. So this is kind of the general Mahanadi. This is one of the blocks where they've done some detailed modeling, looking at the maturity. Again, reservoirs, well, there's a nice combination of both limestone and clastic reservoirs, both shallow and deep water. So there's no shortage of potential for reservoirs in here. And some of it has been mapped using some of the 3D seismic. And you can see that they've done a good job of trying to model some of these submarine channels and maybe submarine fans. You can see, obviously you can see the geometry of this is very significant, a channel and a couple of coalescing submarine fans. So good potential for reservoir, and some of it has been mapped. Here's a model to give you a feel for it. Obviously, this is what we expect, and it's sort of an odd offboard moving into a deep water basin. And traps. So there's been a number of trap types defined: anticlines, onlaps, stratigraphic, structural. Again, this is less structurally complex than the Andaman Basin, so probably the most prospective traps are going to be stratigraphic in nature. And here's an example of one of that. This is one of the major structural features in the area down here in the south. I think this line is right here, and you can see lots of potential for onlap and pinch-out traps associated with that. Again, the calculation, the resource potential has been calculated. This is for the Mahanadi. So discovered is fairly significant, but the resource play potential, undiscovered, is 574 million metric tons. Multiply that times 7, I forget. So I didn't calculate that out, but that's like 350 million barrels, 3.5 billion barrels of oil. So very significant potential for reservoir. And also potential for biogenic gas here, as I mentioned earlier. Look at the Bengal Basin. The Bengal Basin has a little more structural complexity. Again, you can see down here the rifting and these Gondwana sediments. They're controlled more by the structure, but as you go up in the section, you get more into a stratigraphic, simplified section. Obviously, good potential for prograding deltaic type sediments. No shortage of reservoirs through here, and no shortage of oil and gas flows as well. They're very significant, both oil and gas. And I'll point that out. Source rocks, again, there's been some geochemistry, mostly on the onshore wells in the Bengal Basin, but enough to give us a good insight of what the potential for source is. And they've modeled the TOC content as well for the Bengal. And again, we're getting some significant values up to like 1 or 2%, maybe 3%. Again, same range. And again, looking at potential in the Bengal, of course, this is an onshore cross section, but as it extends into the offshore, here's where a lot of the gas shows and oil shows have occurred. So both from the Paleocene, Eocene, Oligocene, and even up into the Pliocene, there are shows of oil and gas. And again, maturation, it's been onshore, there's enough data that we can actually map it, but we can project those oil and gas windows into the offshore and model it, which is what's done here. And again, so we see a strong oil maturity window moving into an over-mature potential gas window. Reservoirs, again, they modeled it, same up, as we move up into the Pliocene, particularly, we're looking at the same sort of setting. You notice there's been a subtle shift in the source of sediment supply between the earlier rocks and the later rocks. This is more north-south, but it has been modeled. And again, potential plate types. So there are structural potential. There's reef buildups in here as well. We talked about the carbonates. There's potential for pinch outs, and obviously some of these turbidites and deltaic deposits and subsea fans that I talked about earlier. So lots of potential for trapping. And again, they've calculated a million metric tons of oil in place potential, undiscovered, of about 219 million metric tons of oil equivalent. So pretty significant. Okay, so that is a very brief summary. We're going to revisit, and you're going to see some of these slides